Hey guys, thanks for tuning in to watch this video today. This video is about addressing common misconceptions in Newton's third law. What is Newton's third law of motion? When there is an action, there is an equal and opposite reaction. Right, the conditions for Newton's third law of motion are as follows. Number one, the action and reaction pairs must be of the same type. So they must be either both gravitational forces or they must be either both normal contact forces. They must be acting on different bodies. And the last one is they must be of equal magnitude. There are a total of 8 misconceptions that I recently found in a research study. The first one is, some people believe that an object with greater mass will exert a greater force on another object. But this idea is not true. When a basketball hits a stationary tennis ball, there exists a pair of equal and opposite force acting on both objects regardless of their masses. So if the basketball hits the tennis ball with a force of 3 newtons, the tennis ball will have a reaction force on the basketball of 3 newtons as well. The second misconception is, some people believe that it is not possible to tell how much a force or a faster runner will exert on a slower runner, or believe that a faster runner will exert more force on a slower runner. But this is not true. When a faster runner collides into a slower runner, there exists a pair of equal and opposite force exerted on both runners regardless of their speed. So if say the man on the left exerts an incoming force of 5 newtons on the slower runner, the slower runner will also exert an equal and opposite force of 5 newtons on the faster runner. The third misconception is, some people believe a pair of equal and opposite forces cancel one another out. But this is not true. There is no way a pair of forces can cancel each other out unless they are acting on the same body. So if you look at the box on the left, I have 2 opposite forces of equal magnitude acting in opposite direction on the same box, and therefore we can say that the 2 forces cancel each other out. But if you were to apply Newton's law of motion, the action and reaction pairs actually act on different bodies. So if you look at the box on the right, if a box is placed on the table, the normal contact force of the box exerted on the table is equal and opposite to the normal contact force of the table acting on the box. But since the 2 Newton forces are acting on different bodies, so they do not cancel each other out. Misconception number 4. Some people believe that the normal contact force and weight makes up an action-reaction pair in Newton's third law of motion. But this is not true. Action-reaction pairs must be of the same type of forces and must act on different bodies. So in the case of the box on the table, the action-reaction pair would be the gravitational force of Earth acting on the box, pulling the box downward, and the gravitational force of the box acting on Earth, pulling Earth towards itself. Because gravitational force is an attractive force. There also exists another pair of action-reaction force, which is the normal contact force. So if the box is actually placed on the table, there is a normal contact force of box acting on the ground or the table, and in return there will be a normal contact force of the ground or the table acting on the box. So this makes up another action-reaction pair. The fifth misconception. Some people believe that action-reaction pairs cancel each other out, thus leading to constant motion as resultant force becomes 0. But this is not true. Action-reaction pairs cannot cancel each other out as they are acting on different bodies. To further explain the motion of the objects, we need to compare the masses of the objects. So as you can see on the right, we have apple falling towards Earth. And what makes up the action-reaction pair? It will be the gravitational force of apple pulling on Earth and the gravitational force of Earth pulling on apple, because gravitational force is an attractive force. And that's the reason why moon is always constantly falling towards Earth. By Newton's third law, the forces are of the same magnitude, so let's give them a magnitude of 5 newtons each. And we can apply F equals to ma to look at the motion of the objects. So since the force is the same, both are of 5 newtons, the mass of Earth is significantly larger, so acceleration of Earth towards apple is negligible. But if you apply the same formula on the apple instead, F is the same of 5 newtons, but mass of the apple is significantly smaller. So the acceleration of apple towards Earth is of a significant value. And that is why you only observe the apple falling towards the earth and not the earth falling towards the apple. The last 3 misconceptions will be pertaining to more complex questions. Misconception number 6. Some people believe that in explaining how an interacting body moves forward, only the action and reaction forces between the two interacting bodies should be considered. But this is not true. When a person is pushing a box, multiple action and reaction pairs between the system and the surroundings should be considered. So what do I mean by an interacting body or system? In physics, we call objects bodies or systems, right? So the first system in this case will be the man. The second system is the treasure chest. Right? Most people have the misconception that if I want to see if the man is able to push the treasure chest forward, I must consider the pair of action-reaction force of the man exerting on the treasure chest and the treasure chest exerting on the man. But this is the misconception. This is not true. In considering if the whole system actually moves forward, I have to look at the interacting forces between the system as a whole and its surroundings. So if you look at this picture, right, instead of considering bodies as individual systems, and consider the system as a whole. And the two action-reaction pairs would be the frictional forces exerted on the foot of the man and the base of the treasure chest. So let's give them a value of 10 newtons each, right, since they are on the same surface. So if I want to see if the man is able to push the treasure chest forward, I only consider the frictional forces acting on the system and not on the ground. Right? So I consider the friction acting on the person's foot pushing the person forward, and I consider the friction acting on the box that is opposing the motion of the system. Right? So in order for the man to push the treasure chest forward, the forward motion must be larger than the backward motion. So instead of having 10 newtons and 10 newtons each, I have to have, say, 20 newtons of frictional force acting on the person's foot and 10 newtons of frictional force opposing the motion of the box. That will allow the system to move forward. The 7th misconception. Some people believe that in explaining the motion of interacting bodies, you have to calculate the difference in the forward and the backward forces. So for example, if I have a forward force of 10 newtons and a backward force of 7 newtons, then I can say that an object will move forward with a resultant force of 3 newtons. But this is not always true. Consider a case when a person is pushing a wheelbarrow, or push cart, or a baby pram. The forces acting on the system are all forward forces, but one is opposing the motion of the system, the other is acting in the direction of motion of the system. So if you look at the example below, I have 2 forward frictional forces. The first one is the frictional force exerted by the ground on the man's foot. The second is the frictional force exerted by the ground on the wheel, which opposes the wheel's motion. Why is this so? Because the part of the wheel which comes in contact with the ground is actually backward. So frictional force will be exerted forward. In order for the man to move forward with the wheelbarrow, the frictional force exerted by the ground on the man's foot of 20 newtons must be larger than the frictional force exerted by the ground on the wheel, which opposes its motion. So both are forward forces, but they serve different purposes. So in order to find out what's the resultant force of the system as a whole, you have to take the forward force minus the forward force. So 20 newtons minus 5 newtons, you get a resultant force of 15 newtons. Bear in mind that both are actually forward forces. And finally, the last misconception. Some people believe that the normal reaction force and weight are always of the same magnitude. But this is not true. Consider a stationary box on the slope. The magnitude of the normal reaction force is a vector addition of weight and friction. So if you look at the vector diagram on the right, we have weight acting vertically downwards, and we have a frictional force between the two surfaces acting upwards on the slope. The normal reaction force will therefore be a vector addition of weight and friction. And that will be the end of the presentation. I hope this has given you some insights on common misconceptions in Newton's third law of motion. Feel free to leave some questions or comments down below, and I hope to see you again.